Discussing the return path. After successful completion of this module, you will be able to describe the return path and how it works. Improvements in digital technology and increased demand for two-way telecommunication services have brought new focus on a little-used portion of the cable system's RF spectrum, the return or reverse path. It is crucial when installing these new services that the technician have a basic understanding of what the return path is and how it works. It is equally important to know the effect that the customer drop system will have on those services. Minor defects in cabling in the connectors, as well as improperly installed CPE, can have a tremendously adverse effect on services operating within the return path. For this reason, it is very important that the installer be able to pre-assess and verify the quality of a drop system. Verifying the quality of the drop system should be done before attempting to activate services to ensure their proper functioning when initially launched. Installations of two-way services are much more successful and customers more satisfied with a service when the drop system and CPE connections are maintained at high standards. Signals containing information and data using the return path can be thought as traveling in the opposite direction to those of the forward path. Forward means traveling from the head end toward the customer, as with traditional cable TV programming. That is why the return path sometimes is referred to as the reverse or upstream path. In reality, it is the fact that these reverse signals are of a specific frequency that they can transport information upstream. It is easier to think of the return path as a separate path of different frequency and direction. Click Graphic to see explanation. The graphic shows how reverse signals are generated and start their journey from the far extremities of the coaxial distribution system. From there, they travel back through the cable system to the head end and then interface to the backbone of the network. Each return path signal originates from a device that is connected to the drop system at the customer premises. Examples of such devices are digital set-top terminals, cable modems, and NIUs. These devices generate reverse signals that carry the data destined for the head end and beyond. They also amplify the signals to overcome drop and feeder losses that the signal will encounter on its way to the first of the distribution system's reverse amplifiers. The reverse path uses the same cable as the forward path to the termination device at a customer's site. The termination device transmits the reverse signal out onto the return path at a return frequency to the head end. In addition to handling all the programming sources destined for distribution out to the customer, head ends must also process the signals coming in from the system's return path. The broadband HFC system's return path carries signals from the customer as well as the system component status monitoring data back to the head end for processing. As shown in the graphic, to transport customer-generated voice and data signals to the head end via the return path, initially they are modulated onto subband, 5 to 42 MHz RF carriers generated by cable modems, digital set-top terminals, and by telephony NIU modems. Go to the next screen to learn more. At an HFC optical node, these RF signals are converted to light and carried the rest of the way to the head end over fiber optic cables. An optical receiver located in the head end takes the incoming optical signal and converts it back to the subband RF frequencies. From the optical receiver, the signal is routed to a subband demodulator that reduces the signal further to its baseband components, video, voice, and/or data. Go to the next screen to learn more. Then, depending on the return signal's content and ultimate destination, it can be sent to a forward path modulator for remote video telecasts such as city council or live sporting events, host digital terminal, HDT for voice, or other appropriate device such as a cable modem termination system, CMTS for data. In broadband systems employing 100% coaxial plant, the subband signals are transmitted upstream to the head end aided by periodic return amplifiers housed inside trunk stations. The signal is directly input to a subband demodulator, and from there the process is the same as for fiber optic return path signals. Broadband cable systems use a coaxial fiber optic cable plant to transport telephone calls initiated by their telephony service customers. But quite often, the incoming voice and data transmissions directed to that customer may come from outside the HFC network on the PSTN. These transmissions can arrive as standard voice calls or as digital transmissions from the Internet that contain a mix of VoIP calls and customer downloaded data files. Incoming circuit switch telephone calls originating from the PSTN and destined for the cable system telephony customers coming to the head end on regular phone lines. There they are routed to an HDT. Groups of HDTs act as the interface between the PSTN and customer premises telephony equipment. The HDT equipment bank typically includes call processors, RF head-end modems, and some sort of call housekeeping manager. The HDT places, modulates, these calls onto allocated forward path frequencies for transport along with the rest of the channel lineup to the customer premises. IP telephony and Internet services both are digital technologies and are processed slightly different than standard voice telephony signals when they arrive at the head end. VoIP and Internet data are transported as packets of data. Each packet contains information used to direct the data to the appropriate piece of equipment. As a result, these services are often called packet switched. A cable modem termination system, CMTS, using the Internet protocol, receives the incoming digital stream, routes, and modulates customer-identified traffic to the appropriate distribution trunk lines. In this exercise, click on all the correct answers. Click Submit when you are ready to get feedback. That's right. Each return path signal originates from a device that is connected to the drop system at the customer premises. That's right. From the optical receiver, the signal is routed to a subband demodulator that reduces the signal further to its baseband video, audio, and/or data components. That's right. The host digital terminal, HDT equipment bank, typically includes call processors, RF head-end modems, and some sort of call housekeeping manager.